Okay, so we solved this problem in the DNA. Now we're going to translate it. Okay, you guys ready? An oil spill is growing in a circular shape. Okay, I've always said underline the math words. Here's the math word, circular. Circular shape. Actually, let's include shape right there. The radius, oh wow, there's another math word, is increasing. Well, that's not really a math word. I suppose you could say it's a math word, but I'm not going to underline it. At a rate, rate is special to calculus because we are studying rates. Like that's half of calculus right there, studying rates. Let's give him a squiggly line because he's so special. And then we have a 5 right there, miles per day. How fast is the area? There's another math word, changing. Changing is the same idea as rate. Because a rate tells you how much something is changing, like miles per hour. How is your distance changing every hour? That's what a rate does. It tells you how you're changing. When the circumference, there's another big word, is 49 pi miles. Wow. There's so much stuff in here. If you just breeze through this reading, there's a good chance you were completely lost. Completely. Just like there's so many math words in here that you don't use all the time. That you would just be you got to read this really slow, maybe 3 times. But anyways, so I don't know what this is. Actually, I don't even know what I'm supposed to do yet. So can you try to identify right now what the problem wants? What does it want from you? Go. Very good. Okay. Yes, it is. How is the area changing? Right? How is the area changing? How fast is it changing? So in calculus, you would normally use a capital A for area. And so I want to know how fast or how is the area changing. This is a rate. This represents a rate. I want you guys to get used to seeing. dA over dt. How is the area changing over time? So this is what we're looking for. We're looking for dA over dt. Another thing, like when you're doing problems like this, you got to be good with identifying the different variables or the different numbers. Like this 5 right here. You see this 5? That's a rate. It says that it's a rate. And so what rate is it? I mean, I know it's a rate, so we're going to have a dt thing here with it equals 5. But it's a rate of what? The radius. The radius is changing, so then you would write dr. Does that make sense? So this is dr over dt. That is how the radius is changing. And it says miles per day. And in these problems, the labels are very important. So miles per day. Since it's a 5, it's like 5 miles per 1 day. But we don't normally write 5 divided by 1. Okay, and now we have another number right here that we haven't identified yet. That one is circumference. The circumference is 49 pi. Okay, so we're kind of understanding all of the information given to us. We know that we have an oil spill. It's in the shape of a circle. The radius is increasing. That means the circle is getting bigger. And we want to know how fast the area is changing. So what we have to do in this problem, now sometimes related rate problems give you the equation that relates all the numbers together and all the rates. But sometimes you have to find it. So this one you have to find. Can you think of an equation that relates them all? Now, the way I do it is I look at what we're looking for. We're looking for the rate at which this area is changing. So, area. Is there some kind of an equation out there that relates area to all these other things? You guys know what it is? Yeah, pi r squared. Now, how'd you know it was pi r squared? Because it was a circular shape, right? So this information, everything that we see right here, everything that we underlined so far has been really valuable except for circumference. We'll get to him in a second. So we have area equals pi r squared. Now when you start getting good at these, you're going to find your equation and you're going to see if it's going to work. You're going to look into the future, per se. You're going to say, okay, if I take the derivative of this with respect to t, will I get a dA over dt? The answer is yes. Will I get a dr over dt? Yes. And then actually when we take the derivative of this, we'll still have an r. Do I have an r?
Oh, yeah.
Huh. I don't see an r defined anywhere. That might be something that we have to figure out. Okay, so let's finish this derivative first. If I take the derivative of a, remember that was 1. You guys remember doing this?
Yes.
So that was 1, and then we multiply it by dA over dt. And I don't need to have that 1, so I'm going to erase him. And then we have equals. And on this side, remember the pi is not a variable. That is a number. You got to treat him like he's a number, like he's a 5 or something, okay? Now, if he was just a 5, what you would do is you would take this 2 and you would multiply him to the 5, right? So we're going to multiply the 2 times the pi, and then we're going to take 1 away from the exponent so that it's just r. Now, because we're taking the derivative of r with respect to t, we have to assume that r is a function of t. Therefore, we're using the chain rule, which is why we would have a dr over dt. Now, can we find dA over dt? Almost. We have dr. dr over dt is 5, so we're going to plug a 5 into that spot, but we need to have an r. How are we going to find that r? Well, there's one piece of information we haven't used yet. Circumference is 49 pi. Do you guys know the formula for that?
No.
It is 2 pi r, or pi times d, which is diameter.
Oh, yeah.
So I'm going to use r because that's what we're actually looking for. We're looking for the radius. And now I just have to solve for r. If I divide both sides by pi, the pi's would go away, and then I would have to divide both sides by 2. So I divide that by 2, I divide this by 2, and then I get r equals 24.5.
Wait, why did the
Hey, it was the exact same.
So now I have my r. So this is what I would write. I would write 2 pi times 24.5 times 5. That's going to be dA over dt. Now I'm going to leave the pi. I'm not going to multiply them out. Let's just multiply 2 times the 5, which is 10. And then we get 10 times this number, which would just move the decimal over, right? 24 or 245. And then we have the pi right there. So we get 245 after multiplying 2, 5, and 24.5. This is dA over dt. But we didn't do our label. What is that going to be? Now I know area is like a unit squared, but what are our units right now?
miles?
Miles. Okay, so we have miles squared, and then per what? Per day. Now how do I know it's per day? Because the rate at which the radius is increasing was given to me per day. And so this is your answer for this problem.